Hello everyone. So today we'll be solving this LeetCode hard problem. Find longest awesome substring. So before moving on to the problem, I would like to say if you have solved this problem already, find the longest substring containing vowels in even counts. The video solution of this has already been uploaded on our Codehurdle channel. So if you have solved this problem, then this was a medium problem. The problem of find longest substring containing vowels in even counts. So if you are able to grasp the concepts discussed in this problem, then we will simply be able to solve the current hard problem that we are going to discuss. So it is recommended that you watch the concept discussed in this problem and then try to solve this problem on your own, and then come see the solution whether you were able to solve it or not. Now let's move on to the problem statement. So we are given an string s, and a definition of an awesome substring is a non-empty substring of s such that we can make any number of swaps in that substring to make it a palindrome. Now we need to return the length of the maximum length awesome substring of s, and as you can see, the constraints are up to 1e5. So this n square approach will not work here. So, and here also, as you can see, here we will need to find the length of maximum length, and here also we needed to find the longest substring, right? So the problems are very similar here, and the approach of using bitmask plus hashing will be using the same approach here as well. So please solve this problem first and see the solution as well, so that the concept gets into your head, so this problem will also become simpler. So let's see the given input. So here we need to choose a substring, then perform swaps, and to convert it into palindrome. This is what we need to do. Now how can we, what is a palindrome? So a palindrome is simply a string which has a, then we'll have a here, b, so b, c, so c, and so on, right? So every element should have a complement, means corresponding pair on from the end, right? So the occurrence of each pair, means each pair will exist in pair, so occurrence will be even only, except if the length is odd, then we'll have a center element, suppose x. So only this element should have a odd occurrence, and all elements should have even occurrences, right? So this is the meaning of a palindrome. And since we can perform any number of swaps, so we just need to find whether the occurrences of all elements in the current substring that we are accounting is all even, and the number of means characters which has odd occurrences should not be greater than 1, right? Means either it should be 0 or it should be 1. If it is odd length, then one element should have the odd frequency, and if it is even length, then no element should have odd frequency. So I hope the logic of palindrome is clear to you. So moving on to the given input. So if we try to see this substring 2 4 2 4 1 2 4 1. Now we see here 2 is occurring even number of times, 4 also occurs even number of times, and 1 occurs odd number of times. That means since the overall length is odd, so all other elements are occurring even number of times, and only one element is occurring odd number of times. Hence it is possible to convert this into a palindrome. How we can convert it? So since 2 is at the start, so we can shift this 2 to the end to make it corresponding pair. 4 is at the here, so since 4 is already here, and we'll make this 1 here, right? So this is a palindrome. So hence the longest substring which we can make a palindrome here was of length 5, hence the output here is 5 only. Let's see for this given input. So here as we can see, all the elements are distinct only. So if we consider any substring of length 1, it will be a palindrome in itself, and hence the output here is 1. We cannot make any, means 1 2 or 2 3, we cannot make them palindrome because two elements have odd frequency, right? One is also having a frequency of 1 and 2 is also having a frequency of 1. So we cannot make them palindrome because only at most one element can have a frequency odd. Now let's see the given input as well. So in this string, if we see the occurrence of total, means occurrence of 2 is 2, occurrence of 1 is also 2, and occurrence of 3 is also 2. As you can see, like all elements are occurring even number of times and no element is occurring odd number of times. So this, since this length is even, we'll simply like, there will be no center present in palindrome, no center will be present in palindrome, and we'll simply perform swaps to make it a palindrome. So for this 2, let's move a 2 at the end. For this one, move a 2 at the 1, and for this 3, we'll have this. So this will be the palindrome for this, and hence the longest substring here was 6, which is the correct output here. So how will the like if we try to like see the brute force code for the solution for this problem? So brute force will be look like, brute force will look like we need to like account for all substrings I to j, right? So we'll move this I loop from 0 to n minus 1 and move this j from I to n minus 1. Now once we have this substring I to j, we'll find out the occurrences of all characters in this substring, right? And find occurrences minus find frequency or occurrence, frequency of all characters, or here it is digits only because it is mentioned that S consists only of digits. So you can find frequency of all digits in substring, and now find out number of subs means odd counts, odd frequencies. So if number of elements with odd frequency is less than equals to 1, then it is possible, right? Else not possible. If the odd frequency elements are 0, then it will be a even length palindrome, and if it is 1, then it will be a odd length palindrome with a center at the end, at the middle. So this is the approach means that we'll follow in the brute force thing. We'll iterate through all the possible substrings and calculate this frequency of all digits in that substring, and we'll see like whether the number of elements with odd frequency is less than or equals to 1. So let's see the brute force code here. So we initialize the maxi variable with 0, which will represent the maximum length of the awesome substring. We start from the I will be denote the starting point of each substring. We create this map to store the current, means the running frequency count for the substring I to j, right? Then we will increase MP of S of j. Now we will find out the number of elements who have the frequency as odd. So if means the frequency is odd, we will increase this odd count. Now this odd count should be less than or equals to 1, then only the substring that we are making will be an awesome substring. So if this is less than or equals to 1, we will simply update it with the length of the substring I to j, which is j minus I plus 1, and we will simply return maxi in the end. As you can see, like this approach will be of the order of big of n into the number of elements in this map, which can in the worst case go up to 10, because the number of digits will be from 0 to 9, which is 10 digits. Hence it will be in the worst case n into 10, which will give us daily, because n is up to the order of 1e5. So it will be 1e5 into 1e5 into 10, which will 1e11. Hence this will give us daily here. So we need to like optimize this approach to solve it into n, or suppose n into 10 or n log n or something of the order of that. So how do we solve this problem? So as we already discussed, we will be using the same approach of bit mask plus hashing. Now how do we like know that applying bit mask will be feasible here? So we are given like S only has digits, right? And there are only 10 digits. So if we create a mask of the order of 2 to the power 10, which will only have values till like 1024, which means 10 to the power 3. Since we can create means this space is allowed. So hence we can create a bit mask of this size and then try to solve this problem. If it had been like all characters are present, so it will have been 2 to the power 26, with 2 to the power 26. In that case, maybe it would have given us memory limit exceeded error. So since it has given us like it only consists of digits, then that means something, right? So that is like giving us a hint in the direction of like you can use bit masking here. Alright, so this was the first thing to observe. Now how do we like create a mask? So what do we need to find? We need to, for each character we need to know like whether odd or even frequency, right? This is what we needed to find. We need to find the number of elements with odd frequency less than equals to 1, right? This is what we needed to find. So since we already care of odd or even here, we'll not like maintain the overall occurrences, means like A occurs 6 times, B occurs 3 times, C occurs 9 times. We'll not maintain this. Instead we'll represent it in the form of 0 or 1, where 0 represents even and 1 represents 0 represents even and 1 represents odd. So this will be represented by 0, this will be 1 and this will be 1. Okay, now since we have means formulated the problem in the forms of zeros and ones, then now we can create a bit mask. Now how will the bit mask be created? So since we only have elements from 0 till 9, right? So we can create a bit mask of the size of 10 bits, where each bit will denote, where each bit denotes, each bit denotes even or odd, right? So suppose it was 0 here, then 1 here, then 0 here, 1 here, 0 here. That means like 2 has occurred odd number of times in the current substring that we are dealing with, and 0 has occurred even number of times. 1 has occurred even number of times. 4 has occurred even number of times. 3 has occurred odd number of times. Okay. So this is the mask that we will create. Now, what do we need? We need to like develop some algorithm in the order of n like. So we need to do something while we are traversing through the array. We need to optimize it such that if we are at a given index, we are able to like find the answer for this current index, right? So we will need to find the answer for the longest awesome substring ending at this index, right? We need to do some pre-computation so that we are able to do this. So what do we need to do? We will iterate from your channel. Now if we are currently at this index I, we need to do some pre-computations to find the longest substring, means the leftmost start point which will end at index I here, such that it substring is awesome, right? Substring is awesome. This is what we need to find. Now since we are representing the frequencies in the form of a mask, so there can be two cases. There can be two cases, like the length is even and length is odd. Okay. So in the case of even length, what we will do? In the case of even length, all the bits here should be 0, right? That means the occurrences of all the digits in this substring should be 0. Hence, in this case, mask will be 0 only. Means all bits 0. This implies even frequency. Hence, for even length, if we want to find the even length, the mask that we will require should have the value as 0. And for odd length, what do we need? We need one element with odd frequency, right? So out of all these bits that we have, any one bit should be set. Any one bit should be set. So the number will be of the form of, suppose 0 1 then 0 0 0 0, right? So any one bit should be set. This will be the mask. Alright. Hence, what will the mask look like? Mask will look like some 2 की power k, where k is greater than or equals to 0 and less than or equals to 9, right? So in the case of odd, mask will look like something this, and in the case of even, mask will look like something this. Now for a particular I, we need to find the longest, means the leftmost start point, which can give us mask 0 or which can give us mask 2 की power k. So how we'll do it? Let's see. So we are at a given index I and n minus 1. Now for a given index I, let's consider the even case. So what do we need to find? We need to find some substring such that this mask is 0. So if we maintain the overall prefix XOR of all the elements, prefix mask, okay. So how do we get like the value of this? It will be nothing but, means since this will be 0, right? So we need to like find some algorithm such that prefix of I means here this index denotes j. So we need to find this value such that this denotes prefix of j and this is suppose prefix of I. So we need to find prefix of I, the overall prefix, and if we remove this portion prefix of j, then it should give us 0 value, right? The mask 0. That means we need to do prefix of I XOR prefix of j, it should give us 0. And we know like if the XOR of two values gives us 0, then these two values should be equal. So that means the prefix of I is equals to prefix of j. Hence the current mask that we have currently, we'll just find the leftmost occurrence of this mask previously, right? And if we find this leftmost occurrence of this mask, then the means the substring which will have the mask as 0 will be from j plus 1 till I, right? So this will give us the case for even, like we'll maintain a map, an ordered map, or we can create a vector also, vector of first occurrence, and the maximum mask value of mask can go up to 2 to the power like 10 minus 1, right? Means all 9 bits are set. So we can create a first occurrence mask of size 2 to the power 10 and initialize it with minus 2. Now initially mask will be 0. So that means we are currently at minus 1 index. So we'll mark first occurrence of 0 as minus 1, right? Now we start the loop from I, 0 till n minus 1. Now at a given index I, what do we need? We need to find prefix of I equals to prefix of j. So we'll do, what do we do? For this mask, the value present at s of I will need to set that bit. So if it was 0, then we need to set 0th bit. If it was 1, then we set the first bit. If it was second, 2 means we'll set the second bit and so on, right? So we need to set the bit according to the digit that is present in the s of I. So what we'll do, we'll set the mask bit of, we'll toggle the bit. If it was set, we'll make it, means if it was unset, we'll make it set, and if it was unset, that means it will make it set. That means initially it was even, now we have one more occurrence, so it will become odd. And initially the occurrences were odd, and now we have got one more value, so the occurrences will become even. So what we'll do, we'll simply do one left shift of the value represented by this. So it will be s of I, and since this is the character, so we'll do s of I minus 0. So to convert it into 0, 1, 2, 3, 4, right? Now this is the mask that we get here is the prefix mask till ith index, right? Now we need to find some j such that that also has the same mask as pre of I. So what do we need? We need to find first occurrence of mask. So that will simply be if it has already, means if this mask has already existed before in the first occurrence vector that we created. So if first occurrence of mask has already occurred, that means it is not minus 2. It has some value of indexes at which it existed before, right? So if it is not minus 2, then what we'll do, we'll update our like the longest result with max of longest. And what do we get? How do we find the length? So we are at index I and we find out some j, means which will be denoted by first occurrence of mask, and so the substring which will have mask as 0 will be from j plus 1 till I, and this will have length of I minus j. So it will be simply I minus first occurrence of mask, right? So this is the case of even length, right? And if it does not already existed before, that means this mask is occurring for the first time. So we'll update its occurrence at the current index, right? So we'll mark it as I, so that we can use this mask that we have got till now for future references, for future I's, right? So this is what we are trying to do. So for the even case, we simply need to find this prefix of j, which is the same as the current mask. And for maximizing the length, since we need to maximize the length, we'll account the first occurrence of that mask only. so that this length is maximized. Now comes the case of odd. So for odd length, what was the case? We need to like find a mask such that prefix of I or prefix of j is equals to mask, and this mask is of the form of 2 to the power k, right? In odd case, what was the mask? The mask was of the form of 2 to the power k. Hence, we need to like find a prefix of j, find the prefix of j such that it is, if we take XOR with prefix of I on both sides, so it will become prefix of I XOR mask, right? So we need to find such prefix of j's such that it is equals to prefix of I XOR mask of the form 2 to the power k. And since k can go up to like belongs to 0 to 9, hence we can account all possible ways of creating this mask of 2 to the power k form and find the first occurrences of prefix of j, right? So this is what we'll do, the same that we did before. Here, since we already knew like what this j will be, which will be the same as the prefix of I, so hence we did this only. But here we need to find this j using, so currently we have the prefix of I as this mask, or it will be one left shift k, okay, and this k will loop from 0 till 9, okay. And at each step we'll find if the first occurrence of means first occurrence. So this is the required mask. So if the first occurrence of this required mask is not equals to -2, then we simply update with I minus first occurrence of required mask, the longest, right? So these were the two cases. The first case was the same case that we discussed in the previous problem as well. The means this problem only had a single case of even values, and here we have a one new case which makes it hard, like the mask can be of the form of 2 to the power k. Okay, so we needed to identify this, that for odd case the mask will be of the form 2 to the power k, and on the basis of that, since this denotes prefix of I, this will be of the form of 2 to the power k, so the prefix of j will be prefix of I XOR 2 to the power k, and for all values of k from 0 to 9 we find this. Hence this is what we'll do, and at each step we will update our answer, means the longest value, if that mask has already required mask has already existed before. So like as we can see, the complexity here would be, for even case we'll get the answer in big of 1 only, and for odd case we'll get the answer in big of 10, because k will go from 0 to 9. So the overall complexity will be n into 10, and since we have like used vector for finding out the first occurrence, so this will of the order of constant time, so the overall complexity would be n into 10 only, which is acceptable, because 1e5 into 10 is 1e6, which will be acceptable in like 1 second. So let's see the code as well for the optimized approach. So this is a simple code. We created this first occurrence vector of, means to represent the maximum value till 2 to the power 10 minus 1, right, and initialize it with -0. Now initially the mask is 0, so this was pointing at the index -1, so we mark it as first occurrence of 0 is equals to -1. Now we create this maximum variable which will denote the final result of the maximum length that we can get. Now we start the loop. Now for current index I, we will update the mask, means set this bit, where if it was 1, then 1 minus, means 1 minus 0 will give us 1, and hence we set, or means toggle the first bit. If it was 0 it will become 1, and if it was 1 then it will become 0, okay. And then for even length the required mask is 0, so we will simply find the first occurrence of this mask only. So it will be, if this has already existed before, we will update maxi with maxi, max of maxi comma I minus first occurrence of mask. If it is occurring for the first time, then we will mark its first occurrence as index I. Now for the odd length, required mask was the current mask that we have, comma 2 to the power k, right? This is what the required mask was. So the required mask is mask XOR 2 to the power k, and k will go from 0 till 9. And if we again check like whether this required mask has existed before, if it has, then we'll update maxi with I minus first occurrence of required mask and finally return the maxi. This will be the approach of n into 10, which means only if only this case was present, then the same problem that we have already discussed, it would have been a medium problem only. But since it had a extra case of means observing like odd, how the mask will look like for odd scenarios, so this loop has just made it hard. For this it was medium, and we have transitioned from medium to hard. So yeah, the means the concept remains simple only. We just need to create mask and observe like, since the string only has digits, so that gives us a hint like 2 k power 10 is allowed. So we'll use that, and using that we are able to solve this problem. Let's try to submit the code as well. So we'll see like how well it performs n into 10. As you can see, like it runs in 2 ms, which is very fast. So I hope like you are able to like means use the learnings from this problem from this medium problem to solve this hard problem. And this is like what we do mostly. We try to like use the learnings that we already had from previous means solving experiences of problems, and then utilize it to solve the harder problems. So I hope like you'll now be able to use this means bit mask plus hashing phenomenon in like similar problems. And if you have any doubts left, feel free to comment down and I will be happy to help. Thank you for watching.